This video is for mini lesson 1.4. 1.4 is the last Unit 1 topic that we are going to cover that's going to be on your exam, and it is all about perpendicular and parallel lines. So this first question asks us to write an equation of the line that goes through the given point and is parallel to the given line, and then to explain our reasoning. So let's first think about this word parallel. Parallel lines have the same slope. So what that means is if I were to take a ruler or some kind of straight edge and to draw a line that is parallel to this line that goes through this point, it's going to be a line that has the same slope. So it's going to look something like this, having the same slope, and what that means geometrically speaking, in terms of geometry, is that these two lines will never intersect, they'll never touch, because they both will have the same slope and they'll keep going in the same direction forever and ever and ever, and they will never touch. So before I draw that, I'm going to make sure I'm very accurate. So I'm going to figure out the slope of this given line, and then once I figure out the slope, then I can draw a line with that same slope. So I'm going to use rise over run. I'm going to pick, doesn't matter which 2 points I pick, but I'm going to pick this one. And I can see between rise is equal to 2. And the run is equal to 3. So when I calculate the rise divided by the run, I'm going to get 2 divided by 3. I also like to just double check that the sign of my slope is positive. So I ended up with a positive slope, positive 2 over 3, and it looks like my line is increasing or going up from left to right. So it makes sense that I got a positive slope. So now I'm going to construct a line that's parallel. So it's a parallel line, it has to have the same slope. So I'm going to draw a new line that also has the same slope of 2 over 3. And I'm going to make sure that this new line goes through the point I was given. Hopefully you can see the point is right here. Okay, so it's going to go, I'm going to go rise 2, run 3, rise 2, run 3, rise 2, run 3. I'm going to end up with these points. Go ahead and connect those points to get my parallel line. Okay, so now that I have my parallel line, I could just visually figure out the equation. So I can see the y-intercept is positive 2. I already know the slope is 2 over 3 to put together my line. I'm also going to show you a different strategy to figure out the equation in the case that you don't have a visual representation. So if I have y equals mx plus b as my equation, I'm going to go ahead and plug in my slope for m and my y-intercept for b. So I get y equals 2 over 3x plus, and then it looks like my y-intercept is equal to 2. All right, and then if I wasn't able to see visually that the y-intercept was 2, then what I could do is, if I had y equals 2 over 3x plus b, I have 3 variables, a y, an x, and a b, and then I also have the point that the line goes through. The point that I was originally given was 3, 4, an x value of 3 and a y value of 4. So I could actually go ahead and plug this ordered pair into my equation, right? Because I know that x value has to be 3 and the y value has to be 4. So I could replace y with 4. I could replace x with 3 plus b. 2 over 3 times 3 is just going to be 2, because this 3 cancels out with the 3 in the denominator, plus b. And then if I were to solve for b, I would get, subtract 2 from both sides, I would get b equals 2. And that's at the same y-intercept that I got visually, graphically looking at the graph. So if you're, for some of these next problems, never forget the strategy that you always have available to you of plugging in an ordered pair, a point with an x-coordinate and a y-coordinate. All right, last example is this perpendicular. Same problem, except one word is changed, and that word is perpendicular. So we're trying to find the line that goes through this point and is perpendicular to the given line. Perpendicular meaning that the slope of that line is going to be the opposite reciprocal. So a quick reminder of opposite reciprocal. What that means, for example, if I were to give you 1 over 2, the opposite reciprocal means the numerator and the denominator flip places. So it becomes 2 over 1. So what's happening is the numerator and the denominator flip places, and then it also takes on a negative value. So the opposite reciprocal of 1/2 would be negative 2 over 1, and we could also just write that as negative 2. So we already know the slope of this given line is 3 over 2. Or sorry, the slope of the given line is 2 over 3. Therefore, the slope of the perpendicular line has to be negative 3 over 2. Perpendicular line slope is 3 over 2. So I'm going to start at the given point, and I'm going to use the slope of negative 3 over 2. So I'm going to go down 3. 1, 2, 3, over 2, and that looks like actually the only point I can fit on the graph, so I'm just going to connect those 2 points to create my line. Okay, so this is the original line, this is the perpendicular line that passes through the given point. So I'm going to go ahead and construct my equation. Y equals negative 3 over 2x plus b. This negative 3 over 2 comes from the opposite reciprocal slope. So now how can I figure out the equation of this line that I just drew, the equation of the green line? I know it has a slope of negative 3 over 2, but I can't see the y-intercept. It goes off of the graph, so how am I going to figure that out? Well, I'm going to use the same strategy. This given point here was 3, 4. So I have the point 3, 4. I know the x value is 3, the y value is 4. So I can go ahead and plug this point into this equation and then solve for b. I encourage you to pause the video and try this on your own and then check your work at the end. So we have 4 equals negative 3 over 2 times 3 plus b. 4 equals negative 9 over 2 plus b. If I do this in my calculator, 9 divided by 2, I'm going to get 4.5, negative 4.5 plus b. And then add 4.5 to both sides. and I will get a final answer of b, or my y-intercept, is equal to 8.5. Plugging that back into my equation, I get y equals -3/2 plus 8.5. And this is the equation of my perpendicular line. Whereas, for example, the first example we did, that was the equation of my parallel line. Okay, so this was a fast summary of parallel and perpendicular lines, learning target 1.4. If you go to the next page of your handout, you have 8 practice problems to try. The first 2 are completed for you, so you can follow along with my steps. And then the answer key for all 8 problems is uploaded to the home page. So go ahead, look through the examples, annotate your examples, complete the next 6 problems, and then check your work on the home page and with your partner. Okay, thank you for your attention. This is the last mini lesson of Unit 1, and next week we will start with reviewing Unit 2. All right, thank you.